Welcome back to Organotope Chem Clinic, where chemistry becomes simple, fun, and exam ready. I am Temitope Adeniji. In this lesson, we are cracking the code of percent yield in chemistry, one of the most common exam questions that confuses many students. What is percent yield? Percent yield is how much product we actually got compared to what should have been gotten theoretically. What is actual yield? Actual yield, also known as the experimental yield, is the amount of product obtained in carrying out a chemical reaction. While theoretical yield is the maximum amount of products that can be obtained from the given amount of reactant in a chemical reaction. During an experiment, a 100% yield means there is no loss at all, while anything less implies that something went missing during such experiments. It may be as a result of evaporation, side reaction, or incomplete reaction. Now let's solve a quick example right here on our CYK1. 22.4 grams of ammonia are produced by a reaction mixture that initially contains 11.2 grams of hydrogen gas and excess nitrogen. What is the percent yield of the reactants? So the first thing we need to understand is, in this kind of reaction, we need to identify the excess reagents as well as the limiting reagents. So the excess reagent in this reaction is a nitrogen gas right here, while the limiting reagent is the hydrogen molecule right here. This reaction will result to Haber process, that is the production of ammonia. So we have our Haber process, which involves the reaction of nitrogen gas with hydrogen gas to give ammonia gas. From our stoichiometry of reaction, there is need for us to balance this chemical equation. I've explained that in stoichiometry right here. You can watch the video lesson. So we need to balance this chemical equation. We have 2 atoms of nitrogen right here, and we have 1 atom of nitrogen in the ammonia from the product side. So there is need for us to add 2 to this, so that we have 2 atoms of nitrogen on the reactant side and 2 atoms of nitrogen on the product side. Then we need to balance the hydrogen atom. On the product side, we have 6 hydrogen atoms, so we balance it with 3 as the coefficient. So 3 times 2, we have 6 atoms of hydrogen. So we've been able to balance the chemical equation. From stoichiometry, the mole ratio for the reactants are 1 mole of nitrogen reacting with 3 moles of hydrogen, resulting into the formation of 2 moles of ammonia, okay, which is the product. So the next thing we need to understand is that since we've identified the excess reagent as nitrogen reagents and the limiting reagents as hydrogen, okay, the limiting reagent is hydrogen. So the next thing we need to understand is, what is the actual yield of ammonia? The actual yield of ammonia is 22.4 grams. Here is the actual yield of ammonia, but we need to determine the theoretical yield. In order to determine the theoretical yield, we have to consider the stoichiometry of the reaction. So can we determine the molar mass of hydrogen gas on the reactant side and the molar mass of ammonia? Because the reaction will come to a stop once the hydrogen gas in this reactant side is exhausted or consumed. So can we determine the reacting mass of hydrogen molecule right here and the mass of ammonia formed? So from here we have molar mass of hydrogen is given as 1 times 2. So we have 2 grams per mole of hydrogen, while the molar mass of ammonia is given as, the atomic mass of nitrogen is 14 times 1 atom, plus the atomic mass of hydrogen is 1 times 3. So we have 17 grams per mole of the ammonia. So from the stoichiometry of the reaction, we can observe that we have the stoichiometric coefficient of the hydrogen molecule as 3, while the stoichiometric coefficient of ammonia is 2. So we have 3 times 2 grams of hydrogen produces, the coefficient of ammonia is 2 times 17 grams of ammonia. Okay, from the question, the actual amount of hydrogen that produces the ammonia is 11.2 grams of hydrogen. Okay, we produce what amount of ammonia? That is our theoretical yield of ammonia. We have X gram of ammonia. Okay, permit me to use X as the theoretical yield of ammonia. So can we make X the subject of formula? We have 11.2 times 2 times 17, that's 34, divided by 2 times 3, 6. So when you press your calculator, you're going to have 380.8 divided by 6. We have 63.47 grams of ammonia. Okay, makes sense? So the theoretical yield of ammonia is 63.47 grams. Moving on, since we have the theoretical yield as 63.47 grams of ammonia and the actual yield is 22.4 grams of ammonia, can we determine the percent yield right now? We use the formula percent yield equals the actual yield. What is the actual yield? Yes, we have 22.4 grams. 22.40 grams over the theoretical yield that we got is 63.47 grams. So we have 63.47 times 100. 35.29%. So the percentage yield of ammonia is 35.29%. Make sense? In real life situation, especially in industrial chemistry, understanding yield helps companies minimize waste and maximize profits. Can we have a quick recap to what we've done today? We considered the writing of balanced chemical equation. So I want to believe that from this question, everyone can balance chemical equation. After that, we move to calculating or determining the theoretical yield of ammonia. Since the theoretical yield is known, so you can always pick the actual yield from the question given, okay? And always note that the actual yield is always less than the theoretical yield. Since we know the actual yield and the theoretical yield for this experiment, we can determine percent yield. Percent yield is the ratio of the actual yield to the theoretical yield times 100%. So in your next experiment, remember that percent yield tells how successful your reaction was. So if you found this video lesson helpful, don't forget to like, subscribe, and share the video with your classmates. Thanks for watching.